Hi, Chris Kuzma here. Today we're going to talk about creating problems involving the accumulation function. So the accumulation function is f of x equals the integral from 0 to x of f of x dx. What? Wait. Okay, immediate problem that we are creating for our students is that the f over here, this lowercase f, looks just like the f over here. And so when we say it out loud, we lose that unless we add in the lowercase f and uppercase f. So f of x equals the integral from 0 to x of lowercase f of x dx. And so we immediately confuse our students. And that's what we want. Okay, well, nevertheless, it's not really a problem to understand what the derivative of capital F of x is, because sort of definitively, derivative of capital F of x is lowercase f of x. But the good news for those of us who are trying to confuse our students is to recognize that at least this f of x and that f of x sound like they're the exact same thing, so students are going to think the derivative of f of x is f of x. So actually, it becomes easier if you use an example. So you can substitute in for the lowercase f of x, we put in the sine of x. And so this is the exact same form as before. So the integral from 0 to x of the sine of x dx is defined as being f of x. Well, now there's no ambiguity, and the derivative of f of x is the sine of x. This makes things much clearer. So don't show that to your students, because if you keep this sine of x as a lowercase f of x, they're much more likely to be confused. We replaced f of x with sine of x, but you might very well give this as a problem. After you gave them this confusing definition, you can then give them this problem which looks like it's solvable, and it is, because the answer is just the sine of x. Okay, so we can change the starting point of the definite integral from 0 to 5. So students will often overlook this 5 down here. And so they might just answer, actually, ironically, the answer is the sine of x, but let's see how that is. Why is it that the integral of f of x is still the sine of x here? So notice that here we're going to define g of x as being the integral from 0 to x of sine of x, which is the same problem we had before. And we know, therefore, what the derivative of g of x is. It's just the sine of x. Notice also that we are hoping for students to know that the integral of g of x from 0 to x of sine of x is the same as the integral from 0 to 5 of sine of x plus the integral from 5 to x of sine of x. In other words, we're integrating first from 0 to 5 of the thing, and then we're integrating from 5 on to x of the thing. So that's just natural, almost intuitive. But then now notice, here's a problem you can give the students. Let's give them h of x equals the integral from 0 to 5 of the sine of x dx. Well, students will frequently answer that the answer to this is sine of x. After all, if we had changed the bottom to 5 and left the x up here alone, then the answer is going to have been sine of x. Well, if we change the thing up here, it probably just doesn't matter what anything in here is. But actually, this definite integral goes from a particular value to a particular value, which is therefore the integral from 0 to 5 of the sine of x dx is the negative cosine of 5 minus the negative cosine of 0. Okay, and this is a nice intimidating value, but it turns out that this is the cosine of 0 is a constant value. The cosine of 5 is a constant value, and subtraction doesn't change anything, and negation doesn't change anything from the standpoint of whether we have a constant. H of x is a constant, and what's the derivative of a constant? Or in other words, h of x, it's 0. So the derivative of h of x is 0. Meanwhile, remember, g of x was this integral from 0 to 5 of sine of x plus the integral from 5 to x of sine of x. Well, that first integral is h of x. And that second integral is f of x. And since g says h of x is a constant value, g of x is a constant value plus f of x, which means f of x is g of x minus a constant value. So the derivative of f of x is, because constant derivative of constant values is 0, derivative of f of x is the same as the derivative of g of x, namely sine of x. So there you have it. It's the beginnings of the kinds of troubles you can give your students involving the accumulation function. And if, by the way, you're a student, this hopefully gives you a clue for how to begin to attack accumulation function problems and avoid some of the confusions that happen from the confusing notations that are common.